have to review my knowledge about slicing. Slicing. So these geometry problems, they normally push you to the limit of what you really understand about Python. Sometimes people also push you to the limit by using things that are not really straightforward. Two to seven, I understand this type of slicing. It's simple enough. 2 to 7 means like it's just getting a subset. With a comma, I never seen that. Okay, so I understand this. If you omit the number on the left, it's basically on the right. That means it goes up to the end. If I omitted this number as well, it would go from the start. I'm not sure why there's a comma. Maybe I'll print it out. Why does it need this anyway? Why can't I just do this? Maybe you can. Oh, don't know if this adds anything. Let's see what it means. Never seen that. Okay. This stands for everything from the beginning to the end, just like for lists. So we're assigning basically 3 to the second row, and it kind of does all of them. So if I didn't use this, I guess I could just use a coordinate and it would go to that coordinate. Let's try it. Oh, I want to see this example. This is me learning some NumPy that I didn't know about. Right. Okay, so let's run this. NumPy. Print A. Right, so if I set A of 1, just like an example, let's see what happens. Right, so what if I, instead of specifying this column, colon, I do like this, right? So what this seems to be the case is that this is to repeat for, basically goes through all the elements. But what if I didn't want the whole row? What if I wanted the second and the third? So 0, 1, 2. Let's see. 1. I'm just guessing here to see, but I think I understand this notation. See, so it misses the first element, so it replaces. Okay, just one thing. I wanted to just clarify something. If I put 1 to 2, is this a stop element or is this an element that's included? It's a stop element, so it kind of is the same as slicing list in this one. So if I wanted to include the last element, can I do this? Yeah. Or I could do something like -1 means the end of the list of the array. No? Oh, because this is a stop element. So the best one is if you want everything up to the end of the list, just don't put anything there. Okay, so I understand what happens when I use a column on the right-hand side. And what happens if I just use a column on the left-hand side? It does all the columns. So let's say I only want to replace the first column for all the rows, then I can do this. That's quite cool. Once you know it, it actually makes it's very simple. If you don't know it, then you scratching your head like me. You'll be scratching your head a lot. Right, so here, this is basically saying, give me all the elements inside here. But this is a single dimensional array, I think. Oh, 3-dimensional array. I'm not sure whether it adds anything to this, because fj will return you the index of the vertex that you want here, right? So let's say 0, 1, 2, 3. I don't really have to specify this second coordinate from what I understand. So this could be just taken out. Okay, but I understand what it's doing here. So for each phase, it basically picks up all the vertices and then adds it as a vector here. So it's just basically a replace function. So if I wanted to simplify my code below, I could just put all these vertices directly inside the vectors. That might be a good idea or not, but I still have to figure out some other things. Okay, so let's go back to our diagram. Okay, it's important to know that our mesh doesn't care about rows and columns, right? The mesh basically just takes in a list of vectors. That's all it is. Each vector has 3 vertices. Okay, so going back to this, I need to create triangles. Yeah, and so I'm going to be using the vertices, so like this. And this is a face. Face 1, face 2, right? And what we are saying is that, so if we have a list of vertices and we are actually storing it in a 2-dimensional array, then our faces need to be numbered according to that. Otherwise we won't be able to identify them. If we're using 2 numbers to identify a face, no, if we need to use 2 numbers to identify a vertex, then you can see how this this technique here will not work, right? Okay, I'm going to just pretend I know what I'm doing. So I'm just going to start coding and hope for the best. All right, so going to copy and paste this. Later on, maybe I'll merge it again. So for x in range of 0 to n columns, from here to here, and then from the top to the bottom. So I'm building up, I can get my vertices. I'm going to try and get it from the list I've already created. Vertices y, x, y, and x. So I need to basically do vertex 1. I need 3 vertices to create a triangle, right? So I'm going to do, so my first vertex here, yeah? Then I'll create a, so I have an option now. So I can use the same row, that will be my second vertex, and then my third vertex will be this one. But actually I need to do 2. So I need to create 1, another one here, and then another one here. And then I need to do the other triangle. So I need to do 2 triangles. But let's do one to start. Simple. So x, y plus 1. Okay, x, this one is okay. So this is in the same column. Then I need to do plus 1. Yeah. And then these 3 vertices will go into the that will be the face. So my face is basically equal vertex 1, vertex 2, and vertex 3. Of course I need to check afterwards like boundaries, because when we get to the end, you know, the last column, there is nothing to basically, there's no more vertices on the right to basically do to add up together. So I need to have a stop somewhere. So I could do a stop here to make sure that I don't end up having an array out of bounds exception, and then the same here. When I get to the bottom, there's no more vertices to go down. So I don't want to have to go up to the very end of the matrix. It's getting complicated, right? Okay, so maybe I'm making it harder than it should be, but let's just start with what we understand. So now I have a face with my 3 vertices. Here, this is a tuple. Then I can add this to my, I should probably use NumPy all the way, because otherwise I end up having compatibilities. So how many faces should I have? I can calculate the number of faces. I didn't want to have to do that. It's the number of faces. So for each, so if we have 4 vertices, right? How many faces we have? We have 2. So if ncol times n rows is my number of faces, so my number of faces is divided by 2. I hope this is right. 2. How does it work if it's an odd number? It doesn't matter. I'm going to use a list for now. Now I'll figure out. But I have a formula somewhere. Might work. So the really, really bad way. Okay. Then I need to go create a mesh. So I can do something like that to create a mesh. So this is just basically using the number of faces that we have. It should be okay. Just converting this to a NumPy array. Everything in NumPy array if I can, to avoid any incompatibilities. So what I'm going to do here is slightly different from the example above. I already have the vertices. So this is going to be, actually I don't think I need to do this. Because it's already 3-dimensional, it has already 3 coordinates. Sorry, this is blowing up my mind. Still need the vertices, of course. Like this. Okay. So this is not cube, I'm going to call it something else, like surface. And let's wait for this to blow up. I'm going to change this to something a bit smaller for now. 10 by 50. It created something. I'm a bit surprised actually, but I doubt it's anything useful. Let's see what. Let's do this. Let's just see what mess I created. Right. So let's save this into a surface. Save it to a file. And we have the file here. I'm going to download it. And I'm going to import it here. Okay, so import STL. And let's see what mess I created. I'll be very surprised if it works first time, given my I wasn't really sure. Oh, not bad. Okay, we have something here. Seems like I missed half of the triangles. Oh, and I think that was meant to be. No, I don't. I mean, like the faces I've defined only did half of the job, right? So this is not a bad result considering how much head scratching I was doing just now. So let's see if we can identify. Let's go into edit mode and have a look at some of the vertices here. So x equal to 49. X equal to 0 here, and y equal to 0. So this is our origin. Let me just move away. Yeah. And now you have here x equal to 0, y equal to 9. So 49. So let me just go back to our... We might have swapped something around, but okay. So it's correct. So x is our... It goes up to 49. So even though I said number of columns 50, it doesn't mean it will have x equal to 50. It will be 0 up to 49. So this is actually not too bad. I've created only one face, but as we saw earlier, I need two, right? So I've only defined the first triangle. If I'm not mistaken, it was this one here. Yeah, I need to define the triangle below as well and see what trouble it gives us. So, right, so let's do that. So I just have to do twice, right? Face 1, face 2. Face 1, then face 2. So face 2 is going to be a bit different. So I'm going to define the vertices again. Create face 1, create face 2. Okay. Right. Right. So the first vertex should be the same, right? So I can leave the first vertex the same. The second vertex is going to be below. So it's going to be y plus 1 and x is the same. Did I? No, that's the one I already defined. So x plus 1 is not, yeah, it's already there. X plus 1 and 0 and y. Okay. First vertex is the same. Second vertex is this one. And then the third vertex is the same as the one is here. So actually the two triangles only differ by 1 point. There's only 1 point that is different. One vertex. Sorry for my English. Okay, so this should be okay. So now I'm adding the first face and the second face. I'm going to count how many faces we have, because I have some doubts about the form I should be using. So length of faces, just no, can do it here. So let's run this. So I have 882 faces. How does that work? So I have 10 rows and 50 columns. So I'm going to download the new surface. And I'm going to import it again to Blender. Let's delete this one, then import one more. Okay. Oh, no, it's correct. This looks like an empty space, but it's not. It's a complete mesh. You see? Am I wrong or not? No, it's not complete mesh. So, unless I've made a mistake. Oh, I have the same point twice. That shouldn't be the case, right? Okay, think. This one is this is the one, should be. So download my surface again, import it into Blender, and yes, this is nice. It looks a very much solid surface. So the next step is basically to have the lithoplane, right? You need to make sure that each of these vertices might have a different height, right? So this, everything right now has height of 0, but then depending on the light intensity, I'm going to give some height to each vertex here. That we have another problem as well, right? So our image is like 3000 pixels of height and 5000 pixels of width, and that's not really like desirable, because it would, first of all, if you want to 3D print that, it's going to be probably going to be too big and too much resolution. And if you have a 3D printer, they won't be able to handle that much of a high resolution. Okay, so I need to take that picture, resize it to something we can work with, and then I can convert each coordinate. I can basically fetch the light intensity for each coordinate. Then we have to define a maximum height and a maximum for each for the lithoplane, and then we, okay, I don't want to get too ahead of myself. So let's see what happens if I really want to have no resizing, right? Okay, we still haven't really, so the number of rows and number of columns should be based on the picture size. So we have our images somewhere here, gray image. How do we get the image size? Let's figure it out. I can do a help. I just want to know the size of the actual image. I'm going to have to use Google. Python PL image size. So to get the image size, should be doing some exercise. So to get the image size, I should shape. Yeah, I am shape. So let's print this. Do this. IMG. Why do I have type here? So obviously I got the wrong documentation. Didn't pay attention. So pillow. Size, width, and height. Okay. Why wasn't that more clear? size. So this is the size. Sorry, this is not the size, I was confused. Here. So the wider number is the width, the lower number is the height. So I can do something like so enclose is the height. Sorry, I didn't have to do this. I can do this. And this will create a very big surface. Too big for us. In fact, if I that, it's still doing it. It might run out of memory. It's going to be an awful lot of vertices. So if I calculate the number of, we're talking about 4,000 times 3,000 roughly. It's 12 million vertices, right? So if you try to render an object, a 3D object with 12 million vertices, you're going to need a lot of memory in disk. And I don't think we have that much to play with. So I need to resize this. I think I might have to kill my, let's do this. So I'm going to resize the image. Because the reason I'm resizing is because I want to make it exactly the size of our mesh in terms of the number I want it to be. For example, if our image is 500 by 500, 500 times 500, I want to have 500 times 500 vertices, right? So it's easier. So I just have to I don't have to do any clever mathematics. Okay, but 500 times 500 is also a lot, so we might not want. So let's resize this image to something smaller. Let's look at the resize function in Pillow. And this resizing can be a bit tricky because depending on how you do it, you need to keep the proportions right. And there's different ways to resize, different techniques. A bit like we had to do with you know, when we converted the image to grayscale, there's different ways of doing it because you need to average out different pixel intensities and different colors. When I try to resize my image, let's just give you a simple example here, right? Okay, so this is my image. I want to resize it to half of what it is currently. So I have 4 vertices times 4, so it's going to be 2. The way it works, right? I need to take this pixel intensity, this pixel intensity, this pixel intensity, and this one, and I need to basically come up with a common, like a value that averages out these 4 pixels. There's different techniques in doing this. So let's find out. Resize. So as you can see, there's like different ways you can calculate these pixel intensities. I'm not going to go into too much detail. I'm just going to use whatever is the default. So what about proportions? It doesn't tell me anything about proportions. Okay, so there's a better way of doing this. So instead of just using the resize function, I can use the thumbnail function. And what the thumbnail function does, it basically takes, for example, I can specify a maximum size, and then it will resize the image up to that maximum size. But depending on the proportion of the image, it might be less in one of the coordinates. That's good enough for me. Let's do this. So let's assume, regardless of what the image is, I'm going to max size, okay. And I'm going to say max size is going to be 500 times 500. This might be too much, we'll find out. And then we resize up to that max size. And based on max size, okay, Okay, it modifies the existing image, so I don't need to do anything. I don't need to reassign the value. So it's a mutable data type in this case. So my new image is already resized, and now I can take the size as before. So let's see if this time it works. 500 times 500 rather than a new dungeon node. Still quite slow. So maybe I'm still 500 times 500 is quite a lot as well. 250,000 vertices. Yeah, it did work. But there must be a massive file, which I don't really want to have to download. Oh, it's not that big. 17 megabytes? 18 megabytes? I'm surprised. Okay, so let's try and open this. Okay, import. I've worked with much bigger 3D models before. Okay, so you can see lots more triangles now. Okay, so we've gone one step forward in our quest to make this a lithoplane.